operations that are implemented as non-member functions due to their operational nature, right? And so a good example will be an inequality function. So what we're going to do is we're going to take a look at a class that represents 2 points in 2D space. And suppose we want to determine if those two objects are equal. What we're going to see is that because we have to have access to the private data of two different objects of the same class type, those are functions that we make friend functions. So we've got our point2D class, which is shown on the next slide here. Well, let's bring this up here. All right, this class is a little bit longer than some of the others we've written, but let's take a look at it. So this is my point2d.header file.h file. Within here, we're defining our class. Its name is point2d, and it has then public functions. So here's its public member functions. It has two constructors. The default constructor takes no arguments. So point2d, remember, a constructor has the same name as a class, does not have a return data type. There's also an initialization constructor that's going to take two arguments. It has the two parameters, one for the x value, one for the y value, right? A point in 2D Cartesian space has an x value and a y value. And then we have member accessor functions, right? Those functions let us then read the data that's stored in our class. And we have two functions, get x and get y. Well, they're returning type double because we have our private data members of our class. One is named x, its data type is double. The other is named y, its data type is double. And those data members are private. That means we need to provide the users of our class some accessor functions to be able to read the data that's stored in those data members. We also then provide what are called mutator functions. Mutator means that we can change. And our functions typically then, so these are typically called setter functions, right? Our accessor functions mean we read data. They're typically called getter functions because we use the word get in the name. Here then we use the word set in a name. So we're going to have a function set x and set y. Neither one of these functions return information, but what we will pass to that function is a value that we want to use to set the data member. And then we have another member function as well called output, and that will actually then print out some of the class information. And what we can pass to that is an OStream object, right? Its parameter name is out, and what that will do is that will allow us to print or pass any sort of OStream object, whether it's a file object or cout, and access the output function, right? And the const here means that our function will not actually change any of the class data members, right? We'll talk about that more in probably the next lecture, right? So for right now, let's just look at this for our class. And then over in our point2d.cpp file, we go ahead and we include our header file, point2d.h, where we define our class. And we start here at the top. I'm defining the default constructor. Remember, the constructors then don't have any return data type, same name as the class name. Remember that every time we define a class function, we scope it with the name of the class. So the name of the class followed by two colon signs. The double colons are the scope resolution operator that says, okay, this function belongs to that class. It's a member function. And that default constructor is simply setting the values of x and y equal to 0. Otherwise, our other constructor, our initialization constructor that has an argument for xval and xy, well, that is just setting the class data member x equal to xval and the class data member y equal to yval. And then our setter functions. So set x doesn't return anything, right? This just matches the prototype over in the class. Again, we have to scope it with the name of the class, let the compiler know this is a member function of the class. If it's a member function of the class, then it's allowed to access the private data members. And so this will then just simply assign val to the class data member x. Same thing here for set y. right? The class data member y will be set equal to the argument val, the local parameter. Get x, get y. Well, they return type double as we discussed before because the class data member is type double. And so get x, that's just going to return whatever value stored in the class data member x. Get y will return whatever value stored in the class data member y. And then the output function, right? There's our OStream reference parameter. All it does is we use the name of that parameter out. Right? We use then the insertion operator, just like we would if this is a cout statement. Right? And we just want to print out a parenthesis, then the value stored in X, a comma space, the value stored in Y, a right parenthesis. So we're just going to print out the XY pair if we call this. Right? Let's take a look at main. And what I'm going to do is we haven't talked about the equality yet. So let's just comment out this portion till we talk about that. And so here in main, right, we're going to create, then I'm creating 3 different points. So P1 is going to have an X value of 3, Y value of 4. So this is calling then the initialization constructor. P2, that calls the initialization constructor, the point 2D initialization constructor. X will be 3, Y will be 4, and then P3, X will be 3, Y will be 5. And so if we just want to print out that information, I've also then created another function here called print point. So this is calling this function print point. And what it's doing is it's printing then, so this argument is a string. This argument, right, is an object of type point2D. And then this argument is that OStream reference. So let's take a look at print point. It expects 3 parameters. The first one is a string, right? Is whatever message is going to be printed out, these arguments then will be passed to this parameter. The second parameter in our list is a reference to a point2D object. The parameter name is P, but it's a constant reference saying that we're not going to do anything to change that object within this function. And then we have a reference to the OStream object. In this case, we're going to pass cout as the OStream object, so we should see our output appear on the screen. And here we use then the parameter name P, right, that object. We call p.out, we call the class member function output to actually then have it print out the point pair value. So if we just run this much, so let me make that a.out. Oh, I did not save my changes. I was like, that should not be printing out the equality results. So that was based on the old code. We will put that code back in, but for now, we just want to see this much. So you can see, right, when we call the print point, right, so here we print it out. In main, we print it out then points. Here when we call print point, right, we're passing this argument P1. We're passing then these objects P1, P2, P3. Because we're passing standard cout, it's writing it to the screen. And then within here, right, since we've called this object P, that object then calls the class function output. It passes that one the OStream object because it requires an OStream object there. Right? And we see that print out on the screen. Now, so far, that seems like a lot of trouble, probably compared to some of the C++ code we've written before. We said, well, okay, maybe we could have stored those values in P1X, P1Y, things like that, and printed it out. But there are reasons we're developing classes. We're going to get to more complicated behavior, implement mathematical libraries or mathematical operations within classes. So for now, we learn these basics. They may seem like a lot of extra work, but eventually there's a good reason for doing it other than just extra work. Again, because we're representing something, right? We're trying to represent an idea of a 2D point, a point in 2D space. What possible operations can that point have, right? So we want to group those like things together and create a representation of that object. That's why we create classes. All right, let's go back here to the lecture slides for a second. All right, so we said then what we want to do is we want to then implement a function that checks to see if two objects are equal. So over here is our class so far on the left. Over here on the right, again, we want to write a function to determine if the two objects of the same class are equal. And we have to then define, well, what does equality mean for two point 2D objects? Well, we'll define the equality as if both of the x coordinates are equal and both of the y coordinates are equal. So if both of those conditions are met, right? If x1 equals x2 and y1 equals y2, then we could say those are both the same points in space, and we'd say they're equal. So we want to write code that looks something like this, right? So remember, these are objects. So I'm saying if object 1.x, so if object 1's x equals object 2's x, and object 1's y equals object 2's y, then object 1 equals object 2, else object 1 does not equal object 2. So sort of a little bit of pseudocode then, right? We want to write code that does something like that. But we don't have a way to do that within a class. We don't have a way to actually write, well, we do have a way. We haven't seen it yet, sorry. We have a way to write a function that requires two different objects of the same class type, but we don't do it as a member function. What we do is we write it as a friend function. So we make a non-member function of the class. And so we're going to call this function equal. It'll return a Boolean of true or false. We're going to pass it then, right, to objects of type point 2D. Right. And so the non-member function, right, we won't scope it with the function, with the class name. So let's take a look at this in the code. Right. So back here, they're in our header file down below. So this is the end of our class definition, right? This is the end of class point 2D. Down here, I've got some comments that say we're going to declare a non-member function. So non-member functions have to be declared outside the class, right? Anything we declare inside the class is a member function. Outside, non-member function, just like any other function you created before, right? So the name of the function is equal. Then it has two parameters, right? One is of type point 2D. Its name is P1. The second parameter is of type point 2D. Its parameter is P2. It's going to return type bool, and this is its header. Right? We end that heading with a semicolon to say this is the function prototype. Right. Now we can go ahead and implement that. And we often go ahead, even though it's a non-member class function, we're going to implement it here in the point2d.cpp file. So we're going to scroll all the way down to the bottom where this is. And again, right, here are some comments here. This is a non-member function definition. So non-member functions are not scoped with a class name, right? And I'm not using the keyword friend here yet. We're not writing a friend function. What we're doing is we're writing this in a way that this takes two objects of type point 2D, right? And what we do here in this function then, right, because this isn't a member of the class, so we don't scope it with a class name, what we have to do is we have to, within here, remember we wanted to say if, right, we could write this another way. We could say if, right, P1.getX equals P2.getX and P1.getY equals, and that should have been a capital Y, I believe, equals P2.getY. So we have to call those member functions. We'd say return true, else that condition was false, else tab key, and then I hit the cap lock, return false. All right, that is what we said we wanted to say, right? Notice because these aren't, right, this isn't a member function of the class, we can't get to the private data members. We have to actually use the accessor function and say p1.getX. We cannot say if p1.x equals p2, double equal sign for comparison, p2.x. We can't do that because this is not a class member function. And so we can't access the private data members like this. We would like to be able to do that. But in writing the function this way, right, it's a non-member function. You can do that. We write lots of non-member functions that take, that have parameter types of classes that we create. We just have to use the accessor functions to get at the data, right? The way I had it written here is more of a shortcut method. I'm just simply returning, I'm performing a comparison that we just did here, right? P1.getX equals P2.getX and P1.gety equals P2.gety. So I'm just returning the result of that. The result of that will be true or false. Right? So either one of these perform the same action. This one's a little more verbose, maybe easier to understand. Less verbose. Had to write a little bit less, maybe a little more difficult to understand when you read it. Right. So if, right, we have that in our code, and back in main, right, we can just call this function. So I've got this other function called print equality. So what print equality does is it's going to take a message, right? The parameter, I call that EQ message. So it takes two parameter messages, EQ message, not EQ message. It's going to take a constant reference to a point2D object and a constant reference to another point2D object. So parameters P1 and P2. And within this function, we are then going to call the non-member function. So that non-member function equal, right? Remember, equal requires two parameters, right? P1 and P2 of type point2D. And we'll go back here to main. So that's why here we're calling that equal function. We're passing it these two parameters, right? And then the call of this function returns true or false. So this is basically going to say, if equal here returns true, we're going to print out the equal message, else this must return false. We'll print out the not equal message. And so when we call this function, notice then the first message I'm passing this string says P1 equals P2. The not equal message, the second string, P1 not equal P2, and then passing it the two objects P1 and P2. We'll do the same thing as well to compare P1 to P3. And if we go back up and we look at our definition, we can see that, well, P1 is constructed with x equals 3 and y equals 4. P2 is also constructed with x equals 3 and y equals 4. So we would expect P1 to be equal to P2. In P3, the x values are the same, but the y values are different. So we would expect P1 to not be equal to P3. And so now, let me clear this out. Let's rebuild, let's rerun. And again, I forget to hit the save button. And if I don't hit the save button, right, our changes don't get compiled in and don't appear in the output. Here we go. So again, we're printing the points so that we can see their values, and right, we get the output P1 equals P2. Yes, we expected that. P1 is not equal to P3. Right. So that is how we handle a non-member function. It's not a friend function. We haven't talked about a friend function yet. And that's what we're going to see with the classes. Like anything else we've done in the C++ language, there's more than one way to write something. So here we write a non-member function that compares if the two items are equal. And let me close those, because what we're going to do is in the next slides, we're going to go look at example 2. So this was point2D example 1. We're just going to go look at these now. Open this. And I'm going to want to copy my make file over there. clean that out. I'm going to copy my make file to the point2d example2. I'm going to change to that directory as well. All right. So I'll be able to work from there. All right. That's our non-member equal function. Right. So friend function. And let me make this bigger so that's easier to read. Right. A non-member function can be given access to private class data members. So private class data members are private class functions. By designating the function as a friend function. Again, friends can access private members. And that means a friend function can directly read from and write to the private data members. It does not have to use any setter or accessor functions. Right? A friend function is not a member. It's not a class member function, but it does have a designation, we'll see, of the keyword friend. Right? Right. Function is defined in the CPP file, right? Like we always do. Here it's shown all in one, but we'll go ahead and take a look at the entire source code. Let's see, functions on scope. Oh, sorry, it's up here. All right. So here's the difference. Over here in class point2d, notice then we have that declaration within the class, returns a bool. We name it equal. All of this looks the same. Bool equal. It has two objects of type point2d, but we give it the friend keyword here. Right? And we do that only here within the class when we declare the function. Right? When we actually write the function, we do not use the friend keyword again. So this part of the syntax, again, becomes more to memorize. And of course, with constant use, then you begin to remember, where do I write friend and where don't I write friend? And if you put it in the wrong place, the compiler will tell you about it. What we're going to be able to do then, right? Again, it's not a member function, so we're not going to scope it with a class name. But what we're going to see is we're just going to be able to access the data members directly. We can say p1.x, p2.x, p1.x, p2.y. Before, remember, when this wasn't a friend function, we had to say p1.getX. We could only get x using the getX member function. So a friend function lets us access the data, right, using the dot operator to go directly to the data. And let's see if that's what we've done here within these files. Okay, so we're in point2d example 2. You can see here is that function bool equal, here is that friend keyword. Right? And some comments here, preconditions. Right? Well, a precondition is before you use this function, you're telling the user P1 and P2 should have some values stored in them. We're telling the user it's going to return true if P1 and P2 represent the same point, otherwise it returns false. We've already discussed that, but these are comments that we often put in our code, right, to let the user know how this works. Everything else in this function is exactly the same, right? The constructors, the member accessor functions, mutators, right? Everything else is the same. But we've got this function equal now within the class. Over here in the CPP file, where that's defined, right, all the way down at the bottom of the file, got a reminder here that this function definition is not scoped with the class name because it's not a member of the class. What it is a friend of that class, nor is the keyword friend used here. Like I said, that can sometimes get confusing. Where do we put that friend word? The friend word goes inside the class declaration here. But when you actually define the function, you don't use the keyword friend again. Right? Again, when we say const, because we're providing a reference to it, what the const does is the const makes the object member data read only, does not allow us to write over it. Right? So we're saying, well, you're a friend of ours. You can read our data, but within this function, we don't want you to write over it. So maybe you're a new friend and we don't trust you fully with our data. We'll let you read our data, but you can't alter our data. All right, that's kind of a silly comparison. All right. And it doesn't look any different over in main. When we actually work with the equal function, nothing in the main program has had to change. Everything in main stays the same because it's a non-member function, right? Again, we just call it by its name. We need to pass it the 2 arguments that we were doing up here as we were doing before. And so everything in main is exactly the same. And let's see if we run make a.out, we see the same output. So from a user point of view, we don't really need to know whether this was implemented as a friend function or a non-member function. All we really need to know is, well, how do we call this function? Right? We call the function by its name and we pass it then the 2 parameters. We know it will return a bool. Right? Same behavior. Again, the difference is right here. We could directly access the data members p1.x versus, and the other one we had to, in the other function, we had to say p1.getX. And why would we want to do that? Right? Why would we want to maybe not do this? The reason we don't want to do this, if we don't have to, is that this is slower. This actually has to call a function and then return the data. So there are more operations required by the computer, right? There are more, and it slows down performance. If we can get directly at the data without going through a function call, because when we go to the function call, then the information about where, so we're leaving the function we're in when we call another function. So we have to put some information on the stack, right? The pointer to where we were at in the program goes onto the stack. Right? We have to then, that lets us know where to return when we come back from a function. And then we actually have to go to the function. We have to perform those operations. Then we're going to return that data back. So another place goes back on the stack for the return data type. So there's some information that gets saved onto the stack and into the system that doesn't happen if we directly access the data ourselves. If we directly access the data member, well, we just go to that area of memory where it already exists and read it, right? We don't have to put anything extra onto the stack. It makes our program run faster. So that is why we want to make something a friend function. All right. And let's just make sure. All right. And so that's what this slide talks about, why we want to create friend functions, because we can directly access the member data. It's more efficient than calling the class accessor function. Notice, right, these implementations, looking at them here, you'd have to look at this one and say, if you're directly accessing the data member and you're not scoped with the class name, you must be a friend function in order to work. And this one is more efficient. All right. So that's our end of our introduction to friend functions. We will see examples in homework and other examples in future code. All right. So hope you learned something. All right. Take a break after watching this and come back and learn some more later. Thank you for watching.